of the universe.
Yes.
Okay, and at this point, this is where the whole thing starts from, and then it has been expanding ever since. And this region is our current position now, where we are. Okay,
Yes.
like you see this stuff here, there are galaxies and so on, right? Now, what is the universe to you? What do you think is the universe?
It's a collection of planets, stars, nebulas, galaxies, everything. Everything we know of
Yeah,
exists in the universe.
yeah, really. Everything that exists so far is the universe. Anything you
Yes.
can think of around you, beyond you, and so on. How did the universe come to existence?
From the Big Bang.
Yeah, the Big Bang is a popular one anyway. A lot of people have been talking about the Big Bang, but the detail, I think, you don't have an idea,
Yes.
isn't it? Does the universe have an end?
No, it's always expanding, but maybe after the expansion, there's just an empty space. So the expansion fills the space.
Okay.
So there's like an outside, maybe,
Oh, okay.
like this picture.
Yeah. You feel it's going to get to a limit that it cannot
Yes.
expand anymore.
Yes, maybe.
Okay, in the course of the lesson, we will attempt to answer it. Does the universe have an outside?
Well, that's what I'm saying. Maybe it has an outside.
Okay, like it has like this picture where you have black matter all
Yes.
around this place. Okay, you feel like it's like this cylindrical stuff.
Yes, unless if you want to include it in the universe, then okay.
No, this is just a model anyway. We can't have a clear picture of the whole universe. It's something that is impossible, isn't it?
Yes.
Now, the first and second question can be answered by science because we can observe some of these things. But this question, this one, and this one, the last two questions, does the universe have an end, cannot be answered by science. I'll tell you the reason.
Yes.
Okay? Now, the universe is anything that exists. It's all space and time, all the stars, planet, moon, comets. Just think of it. Meteor, everything.
Yes. Yes.
Okay? Now, the extent of observable universe.
93 billion years.
Yeah.
Light years.
Now, yeah, in diameter. That means half of it should be on one side if you're observing on one side. So far, we're using whatever we have, telescope, whatever, use it. This is the extent we can see of the universe. Okay, so it's so big, isn't it? Now, the Big Bang theory. Now, we have a little detail here of the Big Bang. What it is. The universe, you need to understand that it's about 14 billion years old now. Okay, that means it kicked off 14 billion years ago. The whole universe expanded from something so small, smaller than an atom, but hotter than anything you can imagine. Small and hot. Okay, so in a fraction of seconds, it started expanding, it started growing. It continued to grow in the process. There is a lot of reactions. Energy turned to particles like hydrogen, helium produced along the line. Other stuffs were made, galaxies were made, and so on. Stars were made, and so on. Okay, all up to what we have today. Now, if you look at this picture, this is where it started from, and this is where we are. What did you notice about the change in color?
It's cooling off.
It's cooling off. Good. It's cooling off. Okay. If you look at the temperature, here it's about 10 billion degree, and here it's like negative 270 degrees Celsius, isn't it? Now, evidence of the Big Bang. There are a lot of evidence of the Big Bang. One of the evidence is what we call the redshift. Another evidence is the CMBR, that is cosmic microwave background radiations that we see around us. I'll tell you more about that. For you to understand the redshift, this redshift here, okay, you need to understand the dispersion of white light when it passes through a prism. This is a prism. You've seen a prism before?
Yes.
This is a prism, like a glass prism. When white light strikes the prism, it separates, it spreads out. We call it to different colors, which we call the spectrum of white light. Okay, you get to have red, orange, yellow, green, blue, indigo, and violet. These are the same colors you see in the rainbow. It means rainbow actually is formed from dispersion of white light.
White light, yes.
You get it?
Yes.
Now, the red part of the spectrum have a longer wavelength.
Yes.
And it's faster That's why it's like speed is proportional to wavelength. The faster the light, the spectrum, particular spectrum, the more the wavelength. Okay, so this red have a longer wavelength than the rest. Okay, you should know that. Now, if in any way you allow this spectrum, hydrogen vapor, okay, to interfere with this spectrum, it absorbs certain wavelength from this spectrum. Certain wavelengths. You know, each of these color represent a particular wavelength, right? It absorbs certain wavelength and creates black bands like this from the
Yes.
region it absorbs. These bands are called the absorption lines, okay, or hydrogen absorption spectrum, you can call it that.
Yes.
Do you understand? Now, if these bands are closer to the red line, if they are closer to the red band line, it shows that the bands have been redshifted or the light is redshifted. Do you understand? Okay, we're going to use some of this idea to be able to explain the redshift in this slide. Now, what is a redshift? The redshift simply means the the increase in wavelength, okay, of light when it moves away from an observer. Okay, when you observe a light, you tend to see the wavelength start. Now, notice here that the wavelength is bigger as the objects tend to move away.
Yes.
The wavelength of light. Okay. Now, there's also a phenomenon called the blue shift. In the blue shift, if an object is coming closer to you, the wavelength of light from the object is smaller. So blue shift is like the direct opposite of red shift. You get a smaller wavelength when an object is moving towards you, but when an object is going away from you, the wavelength gets bigger. That's simply a red shift. Or we can also explain red shift to mean the shift in absorption line. Look at this absorption line. Look, notice. Did you see the absorption line here?
Yes.
Rest frame. Now in this second one here, when the light seems to be going away, what did you notice about the absorption line compared with this one?
Is the first two
No, yeah, compare them.
is getting closer.
Closer to the moving away. As if it's moving towards the red side, right?
Yes.
And the other one, the absorption line tends to move away. This one is a blue shift.
Yes.
When lights tend to come towards you, this is what you notice about the absorption line. Remember I told you it was created by hydrogen vapor.
Yes, teacher.
Okay. Now, when it tends to move away, it moves towards the red line. That is also redshift. So we can say redshift is a shift in absorption line in the spectrum of white light towards the red part of the spectrum of white light. Good?
Yeah.
Okay. Now, observe this. Look at this. At a point, astronomers studied light from distant galaxies, and by 1920 they came up with a useful conclusion. Okay, they observed that light that from distant galaxies tend to be redshifted. You understand what I mean?
Yes.
Their wavelength tend to be bigger. So it's a conclusion. For something moving away from you, it means the wavelength is going to get bigger, right?
Yes.
So in this case, they concluded that this light from this galaxy, or this galaxy itself, it's moving out, it's moving away. Okay? Now, galaxies must have started off from a point before they move apart. True or false? They must have kicked off from a point before they move their separate ways, right?
Yes,
So
yes.
that's one evidence of Big Bang. So all the galaxies must have started from a point and then they are moving apart, because when you observe them, they tend to be moving away. Okay, so they must have kicked off from a point, certain point. Good. Now, scientists also observe that the wavelength of light giving off from the galaxies are moving away. The longer, the wavelengths given away are longer than expected. Okay, much more longer, which is a redshift. I've explained that before. Okay, this is what it's noticed here. Here, look at the wavelength of this light. Notice it's longer than this, right? This is a normal case, but this is for a galaxy that is moving further away from us. Another evidence is what we call the CMBR, which is a cosmic microwave background radiation. It's simply the faint glow, okay, of light that fills the universe.
Yes.
Look at this light. Think of all this stuff that you see. They just fill the universe as if something is cooling off, as if they are the lights that are left behind during the Big Bang. Okay, it's like the residue of lights left behind. It's like you heating up something, maybe a rock or something. After heating it up, you notice that in the night, the rock is still radiating some heat. That's similar to this case. Okay, we call it a cosmic microwave background radiation. There's also evidence. This gives us a clear evidence that the universe is cooling off. It must have started with an intense temperature. Okay, now it's cooling off. It's another evidence. Good?
Yes.
Okay, a timeline of the universe. A timeline of the universe. This is a timeline of the universe.
Yes. So it began 13.8 billion
13
years
point- So
ago.
roughly 14 billion years ago. Good. The birth of the galaxies and the birth of the sun. Our sun is about 4.6 billion years ago, and comets, planets, and all of that. The creation of the moon. Our moon is about 4.5 billion years ago. Okay, and then heavy bombardments from space. 4 billion years ago, the first life was formed, emerged. These are unicellular organisms, single-celled organisms emerged first, about 3.5 billion years ago. Okay, then mammals appeared. These are mammals, right?
Yes.
Dinosaur and primates appeared. Then extinction of the dinosaurs, about 66 million years ago, right?
Yes.
And then the first ancestor of man appeared, that's the ape, 2.5 million years ago, and then 200,000 years ago, the first man appeared. Okay.
Okay.
Anyway, some people will also estimate it to be 500,000 years ago. It's based on different estimates. These are just estimates and so on. They are not clear figure. Okay, the end of the universe. Now, what do you think will happen to the universe? Do you think it's going to have an ending?
Maybe it will stop expanding.
Okay, no, we cannot say for sure whether it's going to have an ending. Do you know the reason why? Because we don't have the
equipment.
technology. Yes, the technology. Okay, we cannot say for sure whether it's going to stop. We cannot say for sure whether it have an outside. Some people call it the parallel universe. These are just conspiracy theories, right? So we cannot say for sure because there are not. We don't have the technology to be able to take some of these measurements of different mass of different items in the universe, right?
Yes.
For now. So maybe as time goes on, we'll be able to say one or two things about the universe. But based on my own assumption, I feel the universe doesn't have an ending. It will continue infinite to an infinite level. That's what I feel for now. Okay, how about you? What do you think? What do you think
That what?
about the universe?
So the universe now is expanding. If it expands and it stops,
Yeah.
it has a chance of maybe some people say that if when it's expanding, it may revert the expansion. Like it will not
Okay,
expand.
get
It
to a
will
certain
de-expand.
point and then they start shrinking back.
Yes.
Okay, whatever is the
It's
case,
a theory.
we cannot say for sure.
We cannot
That's
say
just a theory.
Yes.
Maybe after several certain tests, somebody can come.
Maybe
up with
it will
something
just
useful.
keep expanding.
Okay, yeah, maybe
Maybe
it
it
can
will just
just.
keep
So
expanding.
we are not sure for now.
Yes.
Okay.
But the thing is, it will keep cooling down. It will never stop cooling down.
No, it will never stop cooling down, of course. Since something started from, it will keep cooling down. And what do you think will be the extreme temperature, the lowest possible temperature?
Now it started with how much temperature?
We don't know. Infinitely hot.
Yes.
But so far from the technology, from what we've gathered, the smallest temperature is about negative 273 degrees Celsius. At that point, every particle ceases to move.
And it's in a planet?
Yeah, we don't have any place in the universe that have as low as that.
Oh, okay.
Okay. All right, guys. I want you to like this video, comment, and drop your comment. If you have any question, please leave your question. I'll be glad to answer you. Okay. Have a nice day.